Formation of the Earth. Here are our learning goals. Explain the formation and shape of the Earth. Describe the layers of the Earth and label the following on a diagram of the Earth's structure: crust, lithosphere, asthenosphere, mantle, outer core, inner core. Explain the origin of Earth's heat and describe the Earth's magnetic field. One of the most important theories in the formation of our solar system and solar systems in other parts of the universe is called the Nebular Theory or Nebular Hypothesis. And this is a summary of what the Nebular Hypothesis says. About 4.6 billion years ago, there was a giant cloud of gas and dust called a nebula that was slowly rotating in space. The cloud began to shrink under the pull of its own gravity. The gas and dust particles began to attract each other, and the cloud began to shrink. So here's a little diagram that shows the nebula, and the inward arrows are indicating the force of gravity pulling this together. It's slowly rotating. As it shrinks, it begins to rotate faster and faster. That's just a property of physics. Now, the nebula contracted into a spinning disk due to the pull of gravity. Rather than just being a big blob, it became a spinning disk with a bulge in the middle. And eventually it formed the sun, the planets, and all the other solar system objects. About 90% of the material in this cloud ended up in the sun, and about 10% formed the planets and everything else. So let's look at some pictures that kind of describe this. Here's the cloud. It's slowly spinning. As it's spinning, it begins to contract. As it contracts, it spins faster, and it forms a disk with this bulge in the middle. This is where the sun is going to be, and the planets are going to form out here. The particles in the cloud and the disk begin to attract each other more and more, and clump into larger and larger particles, eventually forming the sun and the planets. So let's look at some of the details of the Nebular Hypothesis. It turns out that when the nebula contracted and formed that spinning disk, the inner part of that spinning disk was warm, and rock and metal dust was common in the inner warm part of the spinning disk, the nebula. The outer parts of that spinning disk, the outer parts of the nebula, were cooler, and gas and ice particles were more common in the outer parts. The ice, dust, gas particles all began to gradually clump together due to gravity, forming larger and larger particles. Gradually, the planets began to form as larger and larger particles clumped together. The inner part of the nebula, where it was warmer and rock and metal dust was more common, you ended up with the rocky planets, the inner planets called Mercury, Venus, Earth, and Mars. The outer parts of that disk, the outer parts of the nebula, where gas and ice were more common, formed what are called the gas giant planets, the outer planets, and those are Jupiter, Saturn, Uranus, and Neptune. In the center, the sun formed, and once the sun grew large enough, it began to shine and produce energy. And when it did that, it produced something called the solar wind. And the solar wind blew away all the remaining gas and dust particles from the solar system. So here's a compact diagram that explains the nebular theory or nebular hypothesis. So we have this large cloud of gas and dust, begins to contract, begins to spin, spins faster and faster, forms a disk. There's a bulge in the center of the disk that becomes the sun. The planets are going to form in the outer parts of the disk. And once the sun began to shine, it created the solar wind, which blew away any remaining gas and dust particles. Now, push pause when you're ready. Push play and hear the answers to the questions. Try and answer them yourself first. So what is a nebula? A nebula is just a giant cloud of gas and dust. What caused our nebula to contract and form the solar system? Well, gravity between the particles of dust and the gas molecules in the nebula. Why are the rocky planets in the inner part of the solar system and the gas giant planets in the outer part? Well, as the giant cloud of gas and dust began to contract, it formed a disk. The inner parts of the disk were warmer, and rock and metal particles were more common there. The outer parts of the disk were cooler, and gas and ice particles were more common there. So in the inner part of the solar system, we got rocky planets that are rock and metal. In the outer part of the solar system, where it was cooler, we get planets made out of ice and gas. What eventually blew away the gas and dust from the solar system? Well, that's the solar wind. Once the sun began to shine, it produces solar wind, which blew away the remaining gas and dust particles. All right, the early Earth was altogether different than what it is now. The early Earth was a giant ball, basically, of lava. It was melted, molten. It wasn't solid. It was a liquid. And because it was a hot liquid, it allowed the early Earth to differentiate into layers. Okay? The heavier, denser materials, like iron, sunk toward the center of the Earth, and the lighter, less dense materials and rock floated toward the surface. So it turns out the Earth ended up with 3 layers if we classify them by what they are made of. Turns out the crust is made out of the light, less dense rocks. The mantle is made out of the heavier, denser rocks. And the core of the Earth is made out of metal, iron and nickel, the heaviest, densest of all. So if we look at a diagram of the Earth, we see that the Earth has 3 layers based on what the layers are made out of. There's a thin outer solid crust. Then there's the mantle. The outer crust is the lightest rocks. The mantle are heavier, denser rocks. And the core is made out of nickel and iron, the densest of all. All right, so hit pause, answer the questions, and then hit play when you're ready to hear the answers. What property of materials that make up the Earth caused the early Earth to differentiate or separate into 3 layers? Well, the density of the materials. The densest materials sank toward the center. The lightest materials floated up to the top. And the materials that were in between in density ended up in the middle. What are the 3 layers of Earth if we classify the layers by what they are made of, their composition? Well, the crust, the mantle, and the core. Now, we can classify Earth's layers in a different way based on their mechanical properties, their physical properties. Basically, whether they're liquid or solid. And when we do that, we end up with 5 layers. The lithosphere is the outer solid layer. Underneath that is a partially melted squishy layer called the asthenosphere. The mantle is solid. The outer core is liquid and the inner core is solid. So let's look at a diagram that compares these 2 ways of classifying Earth's layers. This is the first one we talked about. Composition, what they're made out of. The crust is the lightest, less dense rocks. The mantle are denser rocks. And the core is made out of metal. When we look at them by their physical properties, whether they're liquid or solid, basically, we end up with 5 layers. We have the lithosphere, which is solid, the asthenosphere, which is a squishy liquid, the mantle, which is solid, the outer core is liquid, and the inner core is solid. Now the lithosphere is made up of the solid outer crust and the solid outer mantle. The asthenosphere is the outer part of the mantle that's partially melted, so it's squishy like really thick peanut butter. The mantle underneath the asthenosphere, the rest of the mantle, is solid. The outer core is made of nickel and iron, but it's liquid. And the inner core is made out of nickel and iron, but it's under such great pressure that even though it's extremely hot, it remains a solid. Now these layers are going to be really, really important to us when we talk about plate tectonics in our geology unit, because the lithosphere, the asthenosphere, the mantle, the outer core, inner core allow the outer lithosphere to slide around on the surface of the Earth. So here's our diagram again that compares the layers by their composition versus their mechanical or physical properties, basically whether they're solid or liquid. And the lithosphere is solid. It's made of the crust and the outer solid mantle. The asthenosphere is the outer liquid mantle, squishy mantle. What we call the mantle now is solid. The outer core is nickel and iron but liquid, and the inner core is nickel and iron but solid. So it goes solid, liquid, solid, liquid, solid. All right, push pause. After you've answered the questions, push play. What are the 5 layers of Earth if we classify the layers by whether they're solid or liquid? Well, we have the outer lithosphere. Underneath that, we have the asthenosphere. Then we have the mantle, the outer core, and the liquid core. What makes up the lithosphere? The lithosphere is made up of the solid crust and the solid outer mantle. What makes up the asthenosphere? The asthenosphere is the inner melted mantle. It's squishy. It's like really thick peanut butter. What's the difference between the inner and outer core? The inner core is solid and the outer core is liquid. When we said a minute ago the early Earth was completely melted, it's obviously cooled off quite a bit since it was formed. But the Earth still retains a tremendous amount of heat. The core is at about 6,000 degrees. That's as hot as the visible surface of the sun. And because the Earth has not completely cooled off, and because it's very hot on the inside and cool on the outside, the Earth has active geology, like volcanoes, plate tectonics, earthquakes, things like that. If the Earth was completely cooled off, we wouldn't have geology like that. So where does the Earth's heat come from? What were the original sources of the Earth's heat? Well, there are 3 of them. One is when the Earth formed by larger and larger particles clumping together, they were compressed by gravity. When you compress things, they warm up. The Earth was completely bombarded by meteorites, comets, and asteroids for millions and millions of years, and every time one of those things hit the Earth, it warmed up the Earth. And the last thing, and something that's still going on today, is that radioactive elements within the Earth are decaying, and when they do that, they release heat. Now, the Earth has a magnetic field, which is really important to us, because without that, we wouldn't have an atmosphere, and we would be killed by radiation from the sun. Now, it turns out that our magnetic field is generated by movement of the outer liquid core. The outer core is liquid, and it's in motion, and that creates our magnetic field. So here's the the outer core in motion, and it creates magnetic field, and these are supposed to be the magnetic field lines. So if we were to look at the Earth and we could see the magnetic field lines, it would look like a giant magnet with a North Pole and a South Pole. All right, push pause, answer the questions, and then push play. What causes the Earth to have a magnetic field? Well, motion in the outer liquid core. What are 3 sources of the Earth's heat? Gravitational compression, bombardment, and decay of radioactive materials. Why does the Earth have active geology like volcanoes and earthquakes? Because the Earth hasn't completely cooled off. It's still very hot on the inside.